This is the battery cycling room where we take the coin cells that we made in the synthesis lab and we bring it here, and these are hundreds of channels to test the new chemistries that we developed for the data is recorded in a computer there. These basically run 24/7. We can do a lot of testing in parallel. And for the high-performing cells, we're going to go back and optimize, and eventually we're going to pick out the chemistry that we're going to decide to scale up in the lab downstairs. Okay, so welcome to the lab, the material synthesis lab. And in this lab, we're making a lot of new material chemistries for energy storage, batteries, including both lithium-ion, new kinds of lithium air and lithium sulfur chemistries. And so if you could follow me here. So here we have basic setups for studying electrolytes and for making electrodes, electromaterials. And here we have some furnaces, and we can do CVD and different kinds of chemical synthesis. And this is the space where we make coin cells, which are small batteries that we test for basic small quantities of the new materials, both cathode and anode and the electrolyte. And then this is used in a battery cycler in the other room. And over here we have the fume hood and some more furnaces and electrospinning machine. This is actually an interesting experiment where we are looking at an energy conversion device based on the same principle as battery, where we apply a cyclic mechanical load and convert that load through electrochemical means to electrical energy. So this is a new setup that my postdoc and student have developed. It's a very primitive prototype, but it's working. Standard piezoelectric materials, it converts mechanical energy to electrical energy very rapidly. So it's good for high frequency response, things like sensors. But there are a lot of motion in nature which are slower frequency, for example, human movement. So the instrument here look at slow motion, so a few second frequency, and the best way to convert that into electrical energy. So we've developed a fixture here to look at this mechanical to electrical energy conversion. This is actually the experiment is not being done right now, but this is the current that we see as we squeeze the fixture. We can get very good energy efficiency in converting mechanical to electrical energy.